Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the molar heat capacity of a monoatomic non-metallic solid at 500 Kelvin, which is characterized by an Einstein temperature of 300 Kelvin. Express your results as a multiple of 3R. So when you listen to this question as I've read it, you would notice that we're dealing with a quantum chemistry question, and this is the topic of quantum mechanics in the Atkins Physical Chemistry 11th edition textbook. It's basically chapter 7a. Now we're going to reread the question and write out all our parameters or information we're given. So asked to calculate the molar heat capacity. So usually whenever you have like a reaction, or let's just say a process like this, it usually occurs at constant volume. So the molar heat capacity will be the molar heat capacity at constant volume. So that's CV comma M, which is what we're solving for. And of a monoatomic non-metallic solid at 500 Kelvin. So we've been given the temperature to be 500 Kelvin. We're also told that it is characterized by an Einstein temperature of 300 Kelvin. Now, for those of you who don't know, there's a formula that I use to solve questions like this, and the symbol that denotes Einstein temperature is theta sub E. So this is this, and that is just basically 300 Kelvin. So we're told to express your results as a multiple of 3R. So we're going to need to use a formula to solve a question like this, and the formula is just simply CV comma M, okay, is equal to 3R F sub E T. So that is basically it. And we're told to solve our question and put it as a multiple of 3R. So this 3R would be there. We're not going to use any calculation. By the way, let's not forget what R is. R is simply the gas constant. So we're not going to multiply 3 times the gas constant here. We're just going to focus on calculating what Fe is, and we're going to put our answer in terms of 3R and of course the value of Fe. So now when you go to your textbook, you would also see that the formula for Fe is simply theta sub E divided by temperature all squared times E raised to the power of theta sub E divided by 2T, okay, divided by E would be theta sub E divided by T, and then minus 1 raised to the power of 2, so squared. So yeah, that is it. So this is the F sub E of T. So basically what this is telling us that we're going to have to substitute all of the value for theta sub E as well as T, and we're going to use that to determine Fe. So you have Fe here sub T to equal theta is just simply 300 Kelvin, or say theta sub E. So that's this one, we've gotten this one, divided by T. So this one, that will be 500 Kelvin, all squared, multiplied by E raised to the power of theta sub E. So that would be 300 Kelvin divided by 2T. So that's 2 times 500 Kelvin. So that's that, all squared. All of that divided by E to the theta. So that would be E to the 300 Kelvin divided by T. So divided by 500. Okay, Kelvin. So E to the that minus 1. So yeah, that's it. Minus 1. Gonna mm. So E F of E, or F sub, I don't know why I keep saying F of E. F sub E would be um 300 Kelvin divided by 500 Kelvin. We're going to cancel out here, cancel out this out. So cancel out the Kelvin and the zeros. So we end up with 3 over 5 all squared multiplied by, you have 300 Kelvin divided by 500 Kelvin. So of course you're going to cancel out the Kelvin, cancel out the Kelvin, cancel out the 0, 0, cancel out the 0, 0. So what you end up with is 3 divided by 2 times 5. So that would be e raised to the power of 3 over 10. Okay. Divided by e, cancel out Kelvin, and then 0, 0, and 0, 0. So e raised to the power of 3 over 5 minus 1 all squared. So 3 over 5, f sub e of t is equal to 3 over 5 will simply be 0.6 squared. So I'm changing everything from fraction to decimal because it's just easier for me. Yeah, do whatever is easy for you. You can just instead input this information in your calculator, but I like to do my work step by step because usually professors will like step by step. So you have e 3 over 10 is just simply raised to the power of 0.3 divided by e, and 3 over 5 is again 0.6. So all of this 0.6 or e raised to the power of 0.6 would be it would be minus 1, okay, all squared. So f sub e of t, which is what we're solving for, will be zero point 0.6 squared is simply 0.36, and then e to the raised to the power of 0.3 will simply be, don't forget e is actually a constant that has the value 2.7 something 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 something. Anyways, e raised to the power of 0.3, when you put that in your calculator, you're going to end up with 1.34986 divided by e to the zero point 0.6. We know that to be, when you input in a calculator, you get 1.82211. And then, of course, you've got this one minus 1. So that would be minus 1 all squared. F sub e of t would just be 0.36 times 1.34986 divided by 1.8211. I'm just going to input, um I'm just going to like simplify this a little bit more and then input it in our calculator. So 1.34986, we're just going to have that. I'm just rewriting it, divided by 1.82211 minus 1 is just 0.82211 all squared. So I'm going to input all of this information in our calculator, and I'm going to end up with 2.695982, and then f sub e of t is equal to 0.36. So yeah, that is it. So f sub e of t is equal to 0.97055. So yeah, so f sub e of t is going to simply equal, it basically has equaled this, but you already know as chemists, we don't like leaving our work within messy form. Like, well, let me not say messy form. We want to put it in the proper number of sig figs. So we go back to our question and see the lowest number of significant figures. We see here that we're given two values. We're given the temperature, 500 Kelvin, which is three significant figures. And we're given the Einstein temperature, 300 Kelvin, which is also three significant figures. So we're going to round up. So we end up with our answer to be approximately 0.971 in three significant figures. So this is basically the answer to this part of the question. But don't forget, we're actually asked to calculate CV, comma M. And remember, CV, comma M is equal to, or CV, comma M, yes, the molar heat capacity is equal to 3R f sub e of t. So, and we're told again, when you go back to the question, is express your result as a multiple of 3r. So we cannot multiply 3 times 8.3145 times fe. We have no choice than to just do cv comma m is going to equal 3r times 0.971. So it would be 3r 0.971, or you could also say cv comma m is equal to 0.9713r. So this is basically the answer to this question below. So yeah, that is the answer. If you have any questions, please put it in the comment section. If you have any suggestions or concerns, also put in the comment section. If you would like to see the next question that is very similar to this, make sure you watch the next video on the screen. As well as if you want me to tutor you, I am a tutor who helps students succeed in all their STEM related courses, whether you're in middle school, high school, college. My students have expressed how wonderful my sessions are, and I actually help students succeed in all other parts of academia. So if you would like my tutoring or mentorship services, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.